Welcome to Making Rainbows, Lab Results and Explanations. Your Making Rainbows lab choices were number 1, Raining Rainbows, number 2, Water Prism, number 3, Mirror Mirror Rainbow, number 4, CD Rainbow, number 5, Walking Water, and number 6, Prism Play. Let's explore those labs and find out why we got the results that we got. First, we are going to discuss lab number 1, Raining Rainbows. In this lab, you had to take sun and water to make a rainbow. So why are we able to make a rainbow? Well, it's because the droplets of water refract the sunlight. Essentially, each droplet of water acts as a prism and it refracts the sunlight. And because each color is refracted or bent at a slightly different angle, you see all colors of the spectrum. All right, let's talk about lab number 2, which is Water Prism. In this lab, we had a glass of water that we taped a piece of paper to and had a slit in that paper. How did we make a rainbow? This lab did not give me the brightest or biggest rainbow, but it did give me a little tiny rainbow. How did I make it? Well, the light is traveling from the air and then through the water, and that is refracting that light. Since the sunlight is being refracted, we are able to see all the colors of the spectrum. All right, let's look at lab number 3, Mirror Mirror Rainbow. And this one we had to take a little bowl, some water, and a mirror that's halfway in the water to make that rainbow. See that rainbow there? So how did we make that rainbow? Why did it happen? When you reflect the light out of the water with the mirror, it's reflecting, and you're reflecting that white light, and it's being broken up from that refraction as it travels from the water to the gas. So that's why we see the rainbow of colors, or that full spectrum, in our Mirror Mirror Rainbow. All right, let's talk about lab number 4, which is CD Rainbow. How did we make a rainbow? Well, this is all about how the CD is made. The CD is made essentially as a whole bunch of little mirrors that are side by side. And I know you can't even see those lines with your eyes, but the light is reflected from those narrow mirrors, and they're being reflected at different angles depending on the wavelength. So that's why we're seeing different colors, because we're reflecting different wavelengths. In lab number 5, Walking Water, we dyed each cup of water a different primary color: red, yellow, and blue. And then we put paper towels inside that water. And after 3 weeks and 1 day, all of that water evaporated. So here is where we started and where we ended up. I can see all of those paper towels are now colored from that water. How did we make a rainbow? We made rainbows using those primary colors. The dyed water was absorbed by the paper towels. Those colors were able to mix, so we are able to get other colors. The red and yellow water should have made orange. It doesn't look too orange there, but it's there. The yellow and the blue made a green, but I also see a purple, and I think that's from being with the blue and the red. That purple or that violet was created. Also a little bit of indigo. It's pretty cool to see how those colors were able to be formed. Lab number 6 was prism play. You already know that a prism separates white light into a spectrum of colors. That's why we are able to see a rainbow. All right, that's it for our lab results and explanations about making rainbows, but I still have some things I want to share with you. Check this out. I have this wheel that spins. I call it spinning colors. It has all the colors of the spectrum on it. Red, orange, yellow, green, blue, indigo, and violet. But when I spin it really fast, something happens. What do you think is going to happen? All right, here we go. Spin time. I promise you, there are no tricks here. All I did was freeze the picture. What do you notice happening? That's pretty neat, right? Let's go ahead and try it again and see what happens. Do you see all those colors disappear for a moment and just see white? And then the colors slowly come back. I can see that red, yellow, and blue. And it looks like it's going different directions. Kind of reminds me of my ceiling fan when I watch it at night. So as we lose speed, we are seeing more and more colors. But why did it turn white? Well, because we have all those colors of the spectrum on that spinner, and we know that white reflects all colors of light. So that's why we couldn't see anything when we spun the spinner super fast, because white was there reflecting all colors of the spectrum. You can even make your own version of the color spinner with a pencil and a circle, your own color spinner. I separated mine into 8 equal triangles or slices, and then I colored them. Every color of the spectrum is represented: red, orange, yellow, green, blue, indigo, and violet. By the way, I didn't have an indigo marker. I just colored blue and purple to make indigo. Put a hole in the center of the circle and set your pencil in it. Then you can make your spinner. Can you get it fast enough for it to go white, since white reflects all colors of light? I want to see. Alright, so let's talk about light waves a little bit more to better understand why we see colors. Light is electromagnetic waves, waves of vibrating electric and magnetic fields. The waves carry radiant energy. You already know that light waves do not need a medium to travel through. They can travel through a vacuum and travel fastest through a vacuum. And light travels 300 million meters in 1 second, or 186,000 miles per second. This image shows us the electromagnetic spectrum, or the range of wavelengths of light. And these wavelengths are going to go from longest wavelengths to shortest. So starting with the longest is the radio wave, and then the microwave, the infrared wave. See how they're getting closer together? The wavelengths are getting shorter. Then I can see visible light, and that's the only light that we can see. You can't see radio waves or microwaves or infrared waves, but you can see visible light. And when we look at that, each color has a different wavelength. So look at red. It bends the least, but it has the longest wavelength. Violet has the shortest wavelength, and it's bent the most. As wavelengths get smaller, the frequency increases and carries more energy. If we continue to look at our light spectrum, we were at visible light. Now we're going to the shorter wavelengths. We have ultraviolet light, X-rays, and gamma rays. So the electromagnetic spectrum categorizes radiation from the longest to the shortest wavelengths. This diagram always helps me understand that every color in our spectrum has a different wavelength. And you can see that with how each one of them is a different length and also is bent a different amount. So we are able to see all of them. You already know that whatever color we see is the color being reflected. So if you see red, red is being reflected, and all the other colors of the spectrum are being absorbed. Here's a fish tank at my house. Observe the colors of the fish, the gravel, the plants, because we have different colors of lights in this fish tank. And we're going to see what happens when we put those different colors on. How does it affect the rest of the colors in the fish tank? There is a light reflection from my front door on the fish tank. So you're going to see that in all of these different colors. So don't get that mixed up with your observations. But here is the blue. How does the blue light affect the way the fish tank looks? How does green affect the way everything in the fish tank looks? How does this red light affect what you see in the fish tank? What do you observe about the orange light in the fish tank? What do you observe about the effects of this teal light being used in the aquarium? Pretty sure this light is yellow. So what do you observe about the fish tank using the yellow light? How does the violet light affect what you see in the aquarium? How does this light blue light affect what you see in the fish tank? So out of all of those colors, which one do you think is best for my fish tank? Which one should I use? Why? I definitely wouldn't choose strobe fish tank light. Ugh. It's really interesting how different colored lights can affect what we see or how we see them. In the future, we are going to do another lab where we take different colored filters and analyze how those filters affect what we can see. So I'm interested to see what you think about my fish tank lights and the effects of those different colors. All right, that's it for me. Take care.
Peace.